Let's look at an example of a class that uses class methods. Here you'll see that I've created a new class that I've called date, and in the constructor I have given the parameters for year, month, and day, and in the constructor body I am initializing the instance variables to whatever values we pass in for year, month, and day. And then below the class I've created a date object that I've called date1, and I've initialized it with the values 2023, 12, and 25. Then I have a print function that uses an f string to format this data, and when I run it, we'll get the output year 2023, month 12, day 25. Now let's imagine a scenario where we are creating these date objects based off of a user input. We don't know how the user is going to input the date. They may input it with dashes or slashes or even spaces separating the year, month, and day. And to solve this, we can use a class method. So in my date class below the constructor, I'm going to put in a new method. And the first thing that you'll notice here is this right here, which is a decorator. It starts with the @ symbol followed by the decorator name, which in this case is class method. And if I hover over this, it'll tell us that it converts a function to be a class method. A class method receives the class as implicit first argument, just like an instance method receives the instance. And what that's saying is just like when we put the self parameter up here to receive the instance object itself, this CLS parameter is going to receive the class itself from the interpreter whenever we call this method. We also have this other parameter here that takes the date string, and then in the body of this method, we have year, month, day. So we are trying to unpack a collection into these three variables here, equals map, and I'm calling the map function. And the map function is going to take the list that is returned by calling the split method at the dashes and pass each one of those values into the int function. And then it is going to create a collection of the integers that it was able to create from this string. And then that is going to be unpacked into these three variables here. And then we return CLS and then in parentheses, the year, month, and day that we've gotten right here. And in the return statement here, where we have CLS and then a set of parentheses and then year, month, day, this works exactly the same way as if I were to call date and then pass in these values here. The CLS variable here is acting as the class itself. So now that I have this from string method, if I go down here and for date1, if I change this to be date dot from string, and then in here I pass in a string of 2023-12-25, and I run this, I'll still get the same output of year 2023, month 12, and day 25. But this time I've created the date object using this from string class method. But the way this is set up, it will only work with strings that contain dashes separating the numbers. So let's change that so that it's a bit more dynamic. So I will add a new parameter in here called sep, which is short for separator. And I am going to default it to the dash character. And then down here where I'm calling this split method, instead of passing in a character, I'm going to pass in the sep variable. And if I run this now, this will work just fine because our string is being separated by dashes, and that's what we've defaulted separator to. But if I wanted to use slashes instead, I could replace these dashes with slashes and then put a comma and pass in the slash character. And when I run this, we'll see that I still get the same output, year 2023, month 12, and day 25. And now if I wanted to, I could separate these numbers by any character I want. So even if I wanted to do the dollar signs, I could change all these to be dollar signs. And I will change this to be New Year's. And if I run that, we get the output year 2023, month 1, day 1. So as you've seen in this example, one way to use class methods is to provide additional ways to create object instances of that class. You can also use class methods to modify and work with class attributes. The next thing that we will look at is static methods. I'm going to create a class that will only contain static methods, and static methods are commonly used when a method does not depend on any instance-specific data, but is still related to the class. They are often used for utility functions or helper methods that perform operations related to the class, but do not require any instance state. As you can see here, I created this class called mathUtility, and I have three methods inside of it: add, multiply, and square. You'll notice that I did not create a constructor for this. And If I were to create an instance of the math utility class and try to call these methods, it would not work because the instance object will be passed into this first parameter, and then it would try to add that instance object with whatever value we pass in for b. So unlike when using an instance method, which has the instance object passed in as an argument, or a class method that has the class passed in as an argument, static methods do not have an argument passed into them by the interpreter, and you create a static method by putting the static method decorator above the method signature. So up above define add here, I am going to type the @ character and then type in static method. And if I hover over this, it says it converts a function to be a static method. A static method does not receive an implicit first argument. And I'm going to copy that down to my other two methods here. And down here outside of my class, I am going to create three variables, add, multiply, and square. I'm going to set add to the value of mathUtility.add and pass in the values 1 and 2. And then multiply equals mathUtility.multiply, and I'll pass in the values 3 and 4. And then square equals mathUtility.square, and I'll pass in the value of 6. And then I have a print function that is going to format and output some information down here. And it's important to know that we are not creating an object instance of the math utility class whenever we do this. We are simply getting a value back from this static method that is going to be assigned to this variable. And if I run this, we'll get the output add 3. So 1 plus 2 is 3, multiply 12, 3 times 4 is 12, and then square 36. 6 to the second power is 36. As you can see, static methods are very useful when you have methods that are related to a class but do not require any specific instance related data. That is it for this video. In the next video, we will go over special methods, which are also known as magic or dunder methods.